we just quickly review the idea of the sine and the cosine. If you have an x and a y axis and a circle of radius 1 and a vector from the origin out to the circle, if the vector makes angle theta as measured counterclockwise from the positive x-axis, then the x-coordinate of that vector, which you can get by simply projecting the point at the tip of that vector down to the x-axis, is the cosine of theta. And the y-coordinate obtained by projecting the point over to the y-axis is y equals sine of theta. Now that's only if the radius is 1. If the radius is greater, if the radius was 2, then this would be 2 times the cosine of theta, 2 times the sine of theta. And theta is measured in radians. Starting from the positive x-axis, theta is 0 at this point. As we move counterclockwise, theta goes up to pi over 2, then pi, 3 pi over 2, 2 pi. If we were to continue around the circle, we could then go to 3 pi, 4 pi, 5 pi, 6 pi, etc. around the circle. Now, we're going to illustrate the idea of parametric equations, parametric equations for a curve in the xy plane. We're going to just let x of t be the function cosine of pi t. Now, this is a function you should be familiar with. And y of t equal t squared, another type of function that you're certainly familiar with, probably more so than the trigonometric functions. T is going to be our parameter. So as the value of t changes, the values of x and y are going to change. In this case, they're going to change continuously, and that's going to result in a curve in the xy plane. In order to get a handle on how that works, let's just let t take the values 0, 1/2, 1, 3/2, and 2. Now, I've chosen these values because they result in easily calculated values or easily observed values of the cosine of pi t. If x equals 0, then the cosine of pi t is the cosine of pi times 0, and the cosine of 0 is the x-coordinate at this point, and that's just 1. If you go to 1/2, then you have the cosine of pi times 1/2. Well, pi times 1/2 is pi over 2, and the cosine of pi over 2, if we take this point and project it down to the x-axis, we see that the cosine is 0, so that x of t will be 0. Reasoning similarly, if t equals 1, we have the cosine of pi times 1, which is the cosine of pi. That puts us at this point on the circle, and x is equal to -1. At t equal 3 pi, we have 3 pi over 2. That puts us at this point. The cosine is again 0. And then if t equals 2, cosine of pi t will be the cosine of 2 pi, puts us back at this point, and the cosine is equal to 1. So we see that our values of x of t go from 1 to 0 to -1 to 0 to 1. And we can simply, once we see how these values of t work, we can simply see that as we move around the circle, our x-coordinate goes from 1 to 0 to -1 to 0 to 1. So this is how our x function changes in time. The y function is, of course, a lot simpler. We don't need a picture. We can just square the numbers 0, 1/2, 1, 3/2, and 2, obtaining 1/4 or 0.25, 1, 9/4, which is 2.25, and 4. Now, in the next video, we're going to use the I and j vectors, and the I and j vectors are easily understood. The I vector is just a vector of length 1. It's a unit vector, so it has a length of 1, and it's in the x direction. The j vector has a length of 1, and it's in the y direction. So these are unit vectors, meaning they have length 1. And the I vector is, again, simply understood to be the unit vector in the x direction. The j vector will be the unit vector in the y direction, and you'll see soon why these are important.